Okay, so we have this function. If you go in Desmos and you graph it, it'll look something like this before you restrict the domain. But then they're saying this is only defined when x is less than or equal to -5. Okay, that's important because a function only has an inverse if it passes the horizontal line test. A function only has a proper inverse if it's 1-to-1. That means you could make a horizontal line and it only touches one space in the graph. If we had the full shape U, we couldn't find a proper inverse for this function. Okay, so this can be inverted because it's 1-to-1. Before we try to start doing the algebra for an inverse, let's rewrite by factoring this side. And if you do that, it's x squared plus, it's x plus 5 and x plus 5. Two numbers that multiply to be 25 but add up to be 10. And since that's the same parentheses multiplying to itself, let's make it a little easier. Okay, I just rewrote f of x. To find the inverse, the traditional way of doing it is to switch x and y, so I just replaced f of x with y to start. Now if I switch, I have an algebra problem to solve for y. My first step would be to get rid of that square. I take a square root of both sides, and when you do that, remember you're supposed to consider both positive and negative, okay? And we'll deal with that at the end. So I had to square root both sides to get rid of this square. So that's gone now. But when you square root a square, you got to consider both the positive and negative answers. Okay, and then the last step is to subtract 5 from both sides. So positive or negative square root of x subtracted by 5 equals y. So how do we deal with this? That actually comes back to this point at the beginning where the domain was restricted. Look, an inverse is when you switch the domain and the range. An inverse's domain is the range of the original function. So think back to this original function. What's the range? The range is inclusive, it's true, yeah, so it is inclusive 0 to infinity. That's the range of the original function. 0 is the lowest y value. Infinity is as high as we can go in the y value. So it keeps going up and up. So the domain of this new function, it should also be 0 to infinity. And if we check that, that's true because you can't square root a negative number without having imaginary numbers. So the range checks out. The domain of the original function needs to be the range of the inverse function. So the domain here is negative infinity to -5, right? Because of what it's actually just explicitly said right here. This is the domain. So that should be the range of our function. So this function down here, it better go from negative infinity to -5 on the y-axis. That can't happen if you have a plus here, right? Because the only things that are getting produced by a square root are positive numbers. And so you could plug in like 100, that would give you 5, which isn't supposed to be a part of your range. So basically what we have to say here is negative square root of x minus 5 for the inverse function. I chose the negative sign because of the fact that the domain of the original function is negative infinity to -5. That means the range of my inverse function needs to be negative infinity to -5. So that's why it has to be the negative sign, not the positive sign.